Hi everyone. Today we're going to be continuing our notes on quadratic equations and quadratic functions by exploring the topic key features of a quadratic function. In Unit F, we looked at polynomial expressions that had degree 2, where the largest exponent was 2. These are called quadratic expressions. In this section, we're going to look at the graph of quadratic functions and equations. For example, f of x is equal to x squared plus 10x plus 7. This is a quadratic function. Let's take a look at the graph below. This graph represents the quadratic equation y equals x squared. In contrast to linear equations that have a straight line for a graph, a quadratic equation has a curve as a graph, or like a U shape. So in general, we'll see that quadratic functions are always going to be U-shaped, opening upward, or they might be flipped vertically, so opening downward. Okay? So for all quadratic equations, the graph is going to be a U shape. This graph is called a parabola, and that's going to be our first blank. The parabola is the graph of a quadratic function. The graph of a quadratic function is called a parabola. You might also notice that this graph is perfectly symmetrical. The right-hand side of the graph looks exactly like the left-hand side, just reflected over, say, a mirror. This is called an axis of symmetry, the line for which the function is reflected. So the axis of symmetry is the line that intersects the vertex, which we'll talk about momentarily, and divides the graph into equal halves. The axis of symmetry is the line that intersects the vertex and divides the graph into equal halves. So we can see a couple examples, one parabola opening upward and one parabola opening downward, where the axis of symmetry goes right through the middle of the graph. Each side of the axis looks identical, just reflected. Okay? Now that point where it intersects is called the vertex. Okay, the vertex of a parabola, or the vertex of the graph of a quadratic equation, is the highest or the lowest point on the graph. Or in other words, it is a maximum or a minimum of the graph of the function. So you can notice here this function, it's all entirely positive except for y equals 0. Okay, so the whole function, the range of this function is from 0, and it goes on and on and on all the way up to infinity. It just keeps going on and on. So the range is from 0 to infinity. So the lowest point on this graph is y equals 0, and that would be the vertex. So x equals 0, y equals 0. The vertex is the ordered pair 0, 0. It's the lowest point on the graph. For something like this graph over here, where it opens downward, the vertex is going to be the maximum. It's the highest point on the graph. So all the way at the top of this function is our vertex. Okay. Let's take a look at some of these equations on the TI Inspire. So if you have your TI Inspire, go ahead and take it out, and we'll go ahead and type these in together. So we'll look at the first equation. F of x is equal to 2x squared plus 3x plus 1. So let's go ahead and plug that into our Inspire. Let me open mine up real quick. All right. So here's the TI Inspire. Let me go ahead and make that a little bit bigger for you. In order to graph this, I'm going to open up a new document. So if I'm right here, I'm going to hit New, and I'm going to add a graph. So that's number 2, add graph. And now it's going to pull up the function right here, f1 of x. And so let's go ahead and type in the equation. We have 2x squared plus 3x plus 1. So 2x, I'm going to use the squared key, and then plus 3x and plus 1. And I'm going to hit enter. And let's take a look at the graph. Okay, so the notes are asking us, which way does the parabola open? Does it open up or does it open down? Well, I notice that this parabola opens up. Okay, let's take a look at the equation. The leading coefficient, remember, is the number before the first term of a polynomial in standard form. So the leading coefficient is 2, which is a positive number. Okay. For number 2, let's take a look at the graph of this. So to get back to my functions, I'm going to hit tab. And actually, most of the equation's the same, so I'm actually just going to go up. And that's going to take me back to this original f1 of x. And I want to make that first term negative, that leading coefficient. I'm going to use the negative key. And that's right next to your decimal point. And then I'm going to hit enter. And now I notice that that graph opens downward. So this graph opens down. The leading coefficient is now negative 2, which is a negative number. All right, let's consider the next one. So here we have, I'm going to type in this function. So I'm going to hit tab and then go back up. And I'm going to clear this. You can just spam delete or you can hit control clear. So we have negative 1/2. So I'm going to hit negative. My control divide is going to pull up my fraction bar. And so I'm going to do negative 1/2. Hit the arrow key to get out of that fraction. X squared minus 2x minus 4. So let's go ahead and see what that graph looks like. It's all the way down here. This graph opens downward. The leading coefficient is negative 1/2, which is a negative number. Okay. And last but not least, we'll do the same thing, but with a positive 1/2 for that first number. So I'm going to hit tab to go back to my equations, up to go back to f1 of x. And I'm going to just delete that negative, make it positive. Enter. And we can see that that equation, that quadratic equation, the graph opens upward because the coefficient is 1/2, which is a positive number. So what's the pattern here? How can we tell from the equation whether or not the parabola will open up or down? You could probably guess it. Yes, it has to do with the leading coefficient. When we write quadratic equations in standard form, if the leading coefficient, the number before the first term, is positive, the parabola will open upward. And if it's negative, the parabola will open downward. So let's go ahead and summarize. In general, for the standard form for a quadratic equation is ax squared plus bx plus c. The parabola will open upward when that leading coefficient, a, is positive, and will open downward if it is negative. Okay. So now let's just determine it from the equation. So looking at the equations without graphing them, let's go ahead and determine whether it opens up or down. So for letter A, the leading coefficient is positive 4. This is going to open upward, or the shape will look like this. For letter B, the leading coefficient is negative, so it's going to open downward. The graph looks like that. And finally, the leading coefficient here is negative 1, so this is going to open downward. So we're going to have an upside down U. Okay. Let's go ahead and take a look at the graphs to the left and fill in the blanks. For this one here, does the parabola open up or down? This one opens up. The vertex is the lowest point on the graph. The coordinates are the origin, 0, 0. This is the lowest point on the graph, so this is a minimum. The x-intercepts are where it crosses the x-axis. So looking at the x-axis, there's only one place where it crosses the x-axis, and that's the origin, the vertex 0, 0. Likewise, the y-intercept is where it crosses the y-axis. Every quadratic equation has one y-intercept. This crosses, again, at the origin 0, 0. The axis of symmetry is always a vertical line for quadratic equations, so it's in the form x equals a number. the number that it's equal to is always going to be the x-coordinate of your vertex. So in this case, the x-coordinate of our vertex is 0. Likewise, you could sketch in from the graph the axis of symmetry as a dotted line. And we can see that the line x equals 0 is a vertical line that divides the graph exactly in half. Okay, number 2. Does this function open up or down? This one opens down. The vertex is the highest point on this graph. This has coordinates 3, 4. This is the highest point, so this is a maximum. The x-intercepts, again, is where it crosses the x-axis. I see one here and one here. So we have x-intercepts as ordered pairs, 1, 0 and 5, 0. The y-intercept is where it crosses the y-axis. I see it all the way down here at 0, negative 5. The axis of symmetry, remember, is x equals a number. It's going to be the number of the x-coordinate of your vertex, which is 3. Again, you can also find that by sketching in a vertical line to divide the graph in half, and that vertical line has the equation x equals 3. Okay, let's continue. Go ahead and try this one on your own, and you can pause the video and then unpause to check your work. Letter A, this opens upward. The vertex is negative 2, 1. This is a minimum. The x-intercepts, this doesn't cross the x-axis, so there are none. The y-intercept is 0, 5, and the axis of symmetry is x equals negative 2. Did you get them all right? Let's go ahead and try number 4. So let's go ahead and graph this equation on the Inspire, and we're going to sketch the graph here. So here, I'm going to hit Tab, and I'm going to go back up, and we'll replace the one we were working on earlier. We're going to do x squared plus 8x plus 12. This graph looks like this. So a sketch of the graph, I notice that it has x-intercepts of negative 2 and negative 6. Okay. Oops. So we have 1, 2, 3, 4, 5, 6. So we have one here and one here. The vertex, and I'm actually going to turn on my grid lines. So I'm going to go to Menu. I'm going to go to View. And I'm going to go to Grid. And I'm going to do a lined grid. There we go. So now I can see the coordinates for my vertex is negative 4, negative 4. So let's go ahead and plot that too. 1, 2, 3, 4. And we have these coordinates right here. And then let's also go ahead and plot the y-intercept. So the y-intercept is much higher. It's all the way up here. This has, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the y-intercept is 0, 12. So we can go ahead and plot that as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's go ahead and sketch that graph. So remember, it's a U shape. It's opening upward. It's crossing the x-axis at negative 2 and negative 6, and the y-axis at positive 12. Let me go ahead and fix that. Now be very careful when you're drawing these. These do not come to a point or a corner at the vertex. It's got to be rounded at the bottom. So try to round those out as much as you can. Does this parabola open up or down? This opens up. The vertex we discussed is at negative 4, negative 4. The x-intercepts are at negative 6, 0 and negative 2, 0. The y-intercept is at 0, 12. And the axis of symmetry is the x-coordinate. X equals the x-coordinate of the vertex, or negative 4. All right. Let's go ahead and create a table of values given the graph. So we need 5 points here, so let's go ahead and identify some of those points. You always want to include like your x-intercepts, so I see 2 here, one at negative 5 and one at negative 1. You want to include your vertex, so that's the minimum of this graph. Maybe the y-intercept. And then we need one more point. Well, I know that the graph of a quadratic is symmetrical vertically about the axis of symmetry, right? So I know that if I were to sketch in my axis of symmetry, I know that points of equal distance from the axis of symmetry will have the same y value. Okay? So, like our x-intercepts, for example, are 2 away from the axis of symmetry, and they have the same y value of 0. All the way up here, we have that this is 3 away from the axis of symmetry and has a y value of 5. So that tells me that this point here also is on a lattice pointer. It crosses the grid line really nicely. So that gives us our 5th point. And that's due to the symmetry of quadratic graphs of quadratic equations or parabolas. So now we can plot these points. We get negative 6, 5. We have negative 5, 0. We have negative 3, negative 4. We have negative 1, 0. And we have 0, 5. So these are our 5 points that we're plotting. All right. So if you're ever stuck and you need more points from a graph, just remember that the graph is symmetrical. And so you can always, if you found one on one side, you can find its corresponding one on the other side of the axis of symmetry. All right. So let's go ahead and list the letters that correspond or that fit the descriptions in A through F. So the parabola opens down. Which of these open down? I notice that A opens down, and I also notice that D opens down. Letter B, the parabola has a y-intercept of 0, negative 4. So which ones cross the y-axis at negative 4? I notice that graph B crosses at negative 4. And that's the only one. Letter C, the parabola has an x-intercept of 1, 0. So that's where it crosses the x-axis. Not A, not B. C does. So looks like C is our answer. And D does not. The parabola has an axis of symmetry of x equals 2. So looking at these, which ones are symmetrical about the line y equals 2? X equals 2. The answer, letter A does, B does not, C does, D does not. So A and C. The parabola has a vertex at negative 2, 1. So negative 2, 1, not A, not B, not C, but D. And finally, the vertex of this parabola is a minimum. So graph A, vertex is a maximum, no. Graph B, yes. Graph C, yes. And graph D, no, that's a maximum. So B and C. All right. So in summary, we talked about the key features of the graph of a quadratic equation, also called a parabola. These parabolas are symmetrical about the axis of symmetry. They sometimes have x-intercepts, 1 or 2, or maybe none. All have one y-intercept, and they can open up or down based on the leading coefficient being positive or negative, respectively. All right, so we're going to get a whole lot of practice on this in class. We'll see you tomorrow. Have a great day, everybody. Goodbye.